This video is about the Pythagorean identity for trigonometry, and we're going to establish it using, of course, a blank unit circle. So you'll see a smaller one depicted up in our left corner here. Let's recall that it is on the x and y axes of the coordinate plane. And we're going to bring algebra class back in with us here to trigonometry class to make sure we understand what's going on here. As you might recall, a circle centered at the origin with radius 1, which is, by the way, what the unit circle has. Recall that it extends 1 unit in every direction. A circle with radius 1 centered at the origin has the following formula in algebra class. It has x squared plus y squared equals r squared. But of course, if r is 1, then we get x squared plus y squared equals 1. Now, this formula for a circle is directly related to the Pythagorean theorem, which we're not going to review in detail here yet, but that's why what we're getting to is called the Pythagorean identity. It's very similar to this. Now, let's also recall what we just discussed in defining sine and cosine. So if I have some arc t, I'll extend it here just somewhere in quadrant 1. Its terminal point has coordinates which are x comma y, and that x value is our cosine value. So remember, we said x is cosine of t, and y is the sine value, so y would be sine of t. So if we go back with this new trigonometry in place to the algebraic formula for our circle down here, and substitute, instead of x, we'll put cosine, instead of y, we'll put sine, we get the following equation. Cosine of t, our arc is t, squared, plus sine of t, again arc t, squared, equals 1. Now there's one more way that you'll see this written, which is that, these parentheses get a little cumbersome here. So instead of writing them and holding the squared outside of them in each case, what you'll typically see is the following. You'll see it written as cosine squared of t plus sine squared of t equals 1. So this right here is our abbreviated, or the cleanest way to write, the Pythagorean identity. And again, this will come in handy in many ways, as we can see going forward. Let's now take a look at an example of how we can use our Pythagorean identity to solve a trigonometry problem. So this one says, use the Pythagorean identity to solve. If cosine of t is negative 1/2 and sine of t is less than 0, which means negative, find sine of t. All right, well, this can be done with our Pythagorean identity, which, by the way, let's rewrite up here just for reference. We know it's sine squared t plus cosine squared of t is equal to 1. So if that's our identity, and we know some information we can plug in, namely, if cosine of t is negative 1/2, we'll just substitute that in this equation. So let me rewrite what we'll have, which is sine squared t. Now notice, we don't know what sine of t is. That's not given. All we know is that it's negative. So we'll have to use that eventually, but we don't have a value for it yet. So I'm just leaving sine squared t in the equation. But I do have a value for cosine of t. So instead of cosine squared of t, I'm going to write negative 1/2 for cosine, but then of course it's squared, and I'll set that equal to 1 to finish out our equation. So all we're doing is substituting the known value of cosine in its place in the formula. Now let's do a little bit of the algebra just to simplify this expression. This of course would mean that sine squared of t plus negative 1/2 in parentheses squared would be positive 1/4. So that's all equal to 1. If I subtract 1/4 from both sides, I'll end up with sine squared of t equals, well, 1 minus 1/4 would be 3/4. And then if I want to solve for sine of t, which is what we were asked to find, all I have so far is sine squared of t. But to get rid of the squared, we can apply some of our algebra tricks here and just take the square root of both sides of the equation so that I end up with sine of t equals, and if I reduce the right side here, I'll have square root of 3 over the square root of 4, which is 2. Now, as you might recall from algebra, me taking a square root of both sides of an equation like this means that really I should have a plus or minus in front of this result. That is important, it should be there. However, this is where the other part of the problem comes in. We were told that sine of t is less than 0 or negative, which means I want to use the negative out of my two options for plus or minus to get my answer. So with that being the case, I will now say that the sine of t must be negative square root of 3 over 2. And that's exactly what we were asked to find. Alright, let's take a look at another example using the Pythagorean identity, and this one says to use the Pythagorean identity to solve. If, this time it says sine of t is 1/2, and then it says that t is in quadrant 2, we want to find cosine of t. Well, if we pull our Pythagorean identity back in play here, we'll have sine squared t plus cosine squared of t equals 1. I'm going to rewrite that, but substitute, instead of sine t, I'm going to use 1/2. So really this is 1/2 squared plus, now notice we don't have a value for cosine, so I'm going to leave that as cosine squared of t equals 1. So far all I've done is replace sine of t with 1/2, which is exactly what we were told in the beginning. Now what we do know is that t is in quadrant 2. So just to recall what that even means, let me just get a basic coordinate plane going up here. You'll recall that quadrant 1 is top right, quadrant 2 is top left, 3 is bottom left, and quadrant 4 is bottom right. Okay, and that matters. This, remember, is the x-axis and the y-axis. So that information, that t is in quadrant 2 in this case, will give us some helpful things we need to finish this off. Let's do the algebra required now to solve for cosine of t, similar to the last example where we solved for sine of t. This is, well, 1/2 squared would be 1/4. So 1/4 plus cosine squared of t is equal to 1. If I subtract 1/4 from both sides, I'll end up with cosine squared of t is equal to, if I subtract 1/4 from 1, I'll get 3/4. Then I'll take the square root of both sides to end up with cosine of t is equal to the square root of 3 over square root of 4, which is 2. Now remember, this should be plus or minus here, because I'm taking the square root of both sides of this equation, and the algebra of that requires it. But now we'll go back to our given information, which is that t is in quadrant 2. So if t is in quadrant 2, that's right here, let's consider what the cosine values would be in that quadrant. Remember, cosine pertains to the x values, and the x values in quadrant 2, left of the y-axis, would have to be negative, which gives it away, again, that this should be the negative option out of these two. So we can say that the cosine of t, for this given information, is equal to negative square root of 3 over 2.